All right, let's dive in. So, you've probably heard the term regression tossed around in data science and AI circles. But what does it really mean, and why should you care? At its core, regression is a statistical method used to understand relationships between variables. Imagine you're trying to predict house prices. You know that square footage, number of bedrooms, and location all play a role. Regression helps you quantify how much each of those factors influences the final price. It's like reverse engineering the recipe of a cake based on the ingredients. Now, in the world of AI, regression isn't just a tool, it's a foundational concept. It's how machines learn to predict outcomes. Whether it's forecasting stock prices, estimating customer lifetime value, or even predicting how much energy a building will consume, regression is often the first step. Let's break it down. There are different types of regression, but the most common ones in AI are linear regression. This assumes a straight-line relationship between input and output. It's simple, but surprisingly powerful. Logistic regression. Despite the name, this isn't about predicting numbers. It's about predicting categories. Will a customer churn or not? Will an email be spam or not? Ridge and lasso. Regression. These are used when you have lots of variables and want to avoid overfitting. They add penalties to the model to keep it from getting too complex. Now, why is this important? Before we move on, like and subscribe if you like this information and want more stuff. Because AI isn't magic, it's math. And regression is one of the most interpretable forms of that math. When you build a regression model, you can actually see which variables matter most. You can explain your predictions. That's huge, especially in industries like healthcare, finance, and law, where transparency is critical. Let's take a real-world example. Say you're building an AI model to predict diabetes risk. You feed in data like age, weight, blood pressure, and glucose levels. A regression model will not only give you a prediction, it'll tell you which factors are most influential. That's not just useful, it's ethical. It helps doctors make informed decisions, not just trust a black box. And here's another reason to care. Regression is fast. It's computationally efficient. In a world where data is growing exponentially, having models that can scale quickly is a big advantage. Now let's talk about limitations. Regression assumes a certain structure in the data. Linear regression, for example, assumes linearity. But real-world data is messy. That's where more advanced techniques come in, like decision trees, neural networks, and ensemble methods. But even then, regression often plays a role in feature engineering or as a baseline model. So if you're diving into AI, understanding regression isn't optional, it's essential. It teaches you how models think. It gives you a framework for interpreting results, and it helps you build trust with stakeholders who need to understand what your AI is doing. Let me leave you with this. Regression is like the alphabet of predictive modeling. You can write poetry with deep learning, sure, but if you don't know your letters, you're just guessing. Learn regression, master it, and you'll have a powerful lens through which to view the world of AI.